So we just got done doing multiplying. Now we're going to do dividing. So you are going to divide the coefficients. And real quick, when you did your multiplying, what did you do to the exponents? Add them. So when you divide, you subtract. I taught it to you like a tug of war. Do you remember which side wins? It's that. Okay. Now with these, write what I am about to show you, because what happens is people try to just do it in their head and then they lose track of what's going on. So please just write it. Don't be too proud to actually write down the problem. So we're going to have this whole thing, this 3r squared minus 15r. You want to divide the whole thing by 3r. So you're going to put divided by 3r divided by 3r. It's like distributing, but instead of multiplying, you're dividing. But write it, because if you try and do it in your head, I can guarantee you're going to lose track of what's going on. Again, it's about organization is really what it's about. So then you just do this like two totally separate problems. Just look at that first one. What do you think? 1, because the 3's cancel, so you can write a 1 or just nothing. And then what about the r's? It's just r to the first. You can write 1r to the 1 if you want to, but that's not even necessary. Minus, and now we're going to just do this one. What do you think? It would just be 5, because 15 divided by 3 is 5. And then what happens to the r's? Yeah, they cancel. Or you could think of it as like 1 minus 1 is 0. It's gone. They just cancel. It's nothing, right? So just 1r minus 5 is your answer, right? How many problems did I put on here? 7? We're just going to try that a few more times. That's all that this is, right? So for this one, you're going to write a squared plus 7a minus 28. And you want to divide all of those by 7a. So again, don't be too proud to write it. You're going to divide all of them by 7a. If you try to do it in your head, you're going to lose track. It's not an intelligence thing. I'm not trying to insult your intelligence. It's organization. All right, so when you look at this first one, we're going to just look at that first one. Is there anything to combine with the 7? No. So the 7 is just going to stay where it's at. If you want to draw a fraction bar and just leave the 7 there, it's just all by itself, right? And then do your tug of war. Which side wins for A? The top, by how much? 1. You can put a 1 if you want to, or not. That's fine too. Plus. All right, now we're going to do the 1 in the middle. Now that's kind of an interesting scenario when this happens. Do you see how it's 7a divided by 7a? It's just 1. And you do actually have to put that 1. You know how a lot of times putting the 1 is optional? If the whole thing goes away, you have to put the 1, because otherwise there's nothing else there. But like the whole thing went away, right? Minus 28 divided by 7. Do you guys know that one? It's -4. And then the a does not combine with anything. It just stays where it is. So just like stay down there in the denominator. That's it. You just do it like 3 totally separate problems. Now, this is another way it can be written. Again, do not be too proud to write this out. You're going to copy the numerator and just try not to do a copy error. It's going to be like, hey, Ms. Cole, it looks like you just rewrote the problem. Sure did. Like literally just copy it. And then you're going to divide all 3 of them by 3s squared t squared. Just don't be too proud to write it. But like, oh, I don't need to write that. I'm super smart. It's not about being smart. You're going to lose track of what you're doing. Then you do it as 3 separate problems. So looking at the first one, 9 divided by 3. It's 3. Then look at the s's. Which side wins? The top. By how much? 1. You can put the 1 if you want to. And then what happens to the t's? They cancel. Don't write them. That's it. If you're like, hey, Ms. Cole, what happened to the denominator? Well, you could put 3s over 1 if you want to. Not necessary. All right. Minus. Now do the one in the middle. 15 divided by 3. 5. What about the s's? They cancel. They're gone. And then which side t squared wins? So t goes in the denominator. Why is it just 1t, like t to the 1? Yeah, 2 minus 1 is 1. I usually say how much does it win by? Okay, and then the last one, plus 24 divided by 3. Do you guys know that one? 8. Oh, it is 8. 6 was close. All right. S squared. Well, there aren't any other s's, so it's just going to stay where it is. If it doesn't combine with anything, just leave it where it is. And then which side wins for t? The top. By how much? 1. You can put a 1 if you want to. Just doing it as 3 totally separate problems. 3 minus 2 gives you 1. And you can put the 1 if you want to. Everywhere that there's stuff that's missing, like, look, I could put a 1 here and a 1 here and a 1 here and a 1 here. Like, you can put all those 1s in if you want to. All right. We're just going to try it a couple more times. Copy the numerator. I like this one better just simply because it's A's and B's. I just feel like those are easier to work with than S's and T's. All right, and then you're going to divide all 3 of them by 4AB. And do it as 3 totally separate problems. Thanks for hanging in there while we practice. I can't just do one problem and be like, okay, see you. Like, you have to do a few of them for it to sink in. And that's why we'll play a game too. All right, so for the first one, 12 divided by 4, 3. Good, it would be a to the second. Perfect. And then what happens to the b's? Yeah, they cancel, so just don't write them. Cool. You can put that over 1 if you want to, but you don't have to. All right. Plus, in fact, I don't want to. I'm going to get rid of that. I'm just going to write 3a squared. All right, for the one in the middle, 16 divided by 4, 4. Well, the a, it will be b squared, but the a's cancel out, so just b squared. Remember, if it's the same, you just don't write it. Minus 2, good. The a's cancel and the b's cancel, so that whole thing's gone. That was a little bit of an easier problem. I like that one. It wasn't as complicated. All right, go ahead and flip it over. Oh, this one is x's. That's going to be even easier. We're used to seeing x. Copy the numerator, and you're going to divide them all by 3x. After this one, if it feels like you've got it, I won't make you do the number 6. Again, you just have to do enough so that you feel like you've got it. So for the first one, 6 divided by 3 is 2. And then what do you think about the x's? Yeah, x squared. Good, perfect. 3 minus 1 is 2. Minus, all right, how about the middle? 12 divided by 3, 4x, perfect. And then plus 8. The x's cancel. We feel like we're okay? All right, we'll just do the word problem then. It says the area of a rectangular whiteboard. All right, the way you get an area of a rectangle is length times width, yes? I know you guys didn't take geometry yet, but if you've been alive for over 10 years, you should know length times width, right? Yeah, like just from being alive, you should know that's a rectangle, okay? So if you're given this is the area, the width is 5 feet, find the length. Well, if you take the area and divide by the width, you will get the length, okay? So it's 15t squared plus 20t, and you're going to divide those both by 5t. I try to make the t's a little curly so they don't look like plus signs. You could change it to x if you wanted to. And then just do it like 2 separate problems. So what do you get for the first one? 3t, good. To the 1, if you want to put a 1, plus 4. Good. The t's cancel. And that's your answer.